My name is Carmen Nietzsche. I support the business development for the Pistoia Alliance. The Pistoia Alliance is a not-for-profit life sciences group that is focused on pre-competitive collaboration to promote innovation and efficiency in R&D. And we're delighted to be part here, and I'm delighted to be moderating this panel today. Our topic is unlocking innovation in the lab. Obviously, we spent the last 2 days talking about various aspects of that. What we have learned here today, what we're all experiencing, is a realization that the way we're doing things today it's already changing, but it is going to be dramatically different in the future. And what can we do with our data? What can we do with our processes today to sort of be ready for those dramatic changes that are coming? So we've got a variety of perspectives here on the panel. We'll try to bring ties from what we've had earlier in the meeting, and I'm going to ask that each of the members of the panel introduce themselves and tell us what their relationship is to this topic and the area that is of interest to them. And we'll start with Ellie. Sure.
Hi, that's loud. My name is Eli Groban, and I'm on the BioNano team for Autodesk. Autodesk is a design company. It's a $14 billion, actually now $18 billion software company that focuses on design for cars, bridges, buildings, probably this building, et cetera. So we're most known for AutoCAD. The reason we're here is I got my PhD in biophysics from UCSF, worked in biotech for 9 years, doing a mix of biology, automation, and software, and now Autodesk is grabbing folks like me and putting them at the head of groups like this to get into the life sciences. So leverage the tech that Autodesk has built in various other areas to extend to your work. The reason I believe I'm sitting here is Autodesk as a company moved to the cloud about 5 years ago. We started the transition and we're almost to the end. So cloud-based authentication and software packages rather than just that cloud-based authentication and desktop packages. So we have a lot of knowledge about moving to the cloud. We've helped major corporations like BMW and Mercedes move to the cloud, and we're just now producing cloud products for the life sciences industry.
Right, thank you. Bindu?
Hello, I'm Bindu Raghavan. I lead the lab IT platform for Monsanto. Monsanto is a digital ag company, so that's our mission, is to digitize agriculture. And when you think about that, you're thinking about crops in the field and tractors and harvesters. But in order for us to get those products out there to the farmers, it originates somewhere in a lab somewhere. That's where those products are discovered. That's where those products are tested. The digitization journey, it goes beyond from just the field all the way across to lab, and that's where my interest is in this forum. I would like to understand, how others with labs are going on this digitization journey, and also to share my experiences here.
Thank you very much. Okay, Jeffrey?
Hi, I'm Jeff Kloft. I'm the VP of Digital Solutions for PerkinElmer. PerkinElmer is a large human and environmental health company. I've been in the high-tech industry now for about 30 years, working for some larger companies like Digital Equipment Corporation, Sybase, Citrix, but also been involved in a number of small startup companies, including one that many of you may be aware of called Phase Forward, that brought the clinical trial process out to the internet in the late 90s. I'm a technologist, so I'm sort of the odd guy in the room, right? So I'm not a scientist. I don't even pretend to be one. I'm an engineer and a technologist. So.
Great, thank you, Jeff. And Vasilios.
Hi, Vasilios Panizopoulos from Biogen, where I'm responsible for leading the lab in advanced computing platforms. That includes all of the lab instruments, PCs, the electronic lab notebook environments, LIMS systems, and all of the infrastructure needed to run those environments. Multi-petabyte environment, also responsible for running the high-performance computing and cloud strategies at Biogen. Currently have about 1,000 cores on site, as well as some scaling and bursting capabilities out to some of the cloud providers. Been in the industry now for over 20 years in various pharmas and biotechs, but started off my career in the academic world as a molecular biologist, converted to computer scientist in the late 90s. So been in this space for a bit of time.
Great, so I'm sure you'll have some really good insights in what we're trying to tackle today. So the topic was the unlocking innovation in the lab, and just to kind of set the scene again, we're not, at this point when we're talking about unlocking the lab, we wanted to make it clear we're not just talking about the physical space, but we're really talking about the data in, the data out, everything that's involved, the processes that have to be put in place to deal with that. So we started to think when we were preparing for this, what are some of the prerequisites to getting to that lab of the future, and then what are some of the barriers that we're facing to get there. And we've talked about it quite a bit. I think after listening to Victor with Allergan, we are now convinced that the security issues can be handled. So we want to talk a little bit about, however, moving to the cloud and all of the benefits and aspects of that. And maybe we'll start with Eli, and then maybe Jeff can jump in there.
Sure. So in my view, there are 4 main reasons to move to the cloud. I usually mention 3 of them, but I know Jeff's going to back me up on the 4th. So it depends on the audience I'm talking to. So the 3 that I usually mention are collaboration, infinite compute, and platform independence. If you're looking for those 3 things, the cloud is where you should be going. There are reasons not to move things to the cloud. The cloud is not the hammer where everything is a nail, right? There are certain things that should be on the cloud and certain things that shouldn't be, but for those 3 things, the cloud is the best place to do it. And there is a 4th, and I'm going to mention the 4th, which is security. In my belief, in Autodesk's belief, there's no more secure place than the cloud. Right now, we're entering an era where we're not being hacked by the guy in his PJs eating cornflakes, still living in his mom's basement. We're being hacked by nation states. And the best folks to defend against that are folks at places like Google Cloud and AWS, where they have huge teams who are not only going to monitor for intrusion and try to prevent that, but also know it exists. And I'm not going to mention the major pharmas who have been hacked over the past couple of years, but the issue is not that they've been hacked, but they don't even know it. So you've got China trying to troll for bioprocess information and pulling it, because those are the hard drugs to make in terms of the generics, right? And they're pulling it out of major pharma data centers that are sitting locally in someone's basement, in a sense. So for me, going to the cloud means you are going to be able to collaborate with the person next to you or the person far away. You're going to be able to spin up or spin down as many instances as you want for high performance computing. You're not going to care if someone's using a Mac, a PC, a phone, a tablet, any other device that someone comes up over the next couple of years. And you've got a huge security team watching your back at all times.
Yeah, I'll address the security thing in one way in a second, but one of the other things that sort of came up is, what are the impediments to going to the cloud? I think we're the impediments, right? It's our own sort of insecurities or just not understanding it. I mean, the technology, I'm a technologist, and the technology moves at such a rapid rate. There's not a week that doesn't go by. It's like, all right, I got to do a little lookup on what that is in a little bit more detail. And my background allows me to do it quickly. I can't imagine if you were someone that's like, okay, I don't even know where to begin to look for some of this stuff. So I think there's an element of it's a community effort and sort of trust that it's all moving in the right direction, but that we're potentially our own impediment to this. And to the security issue, I guess the analogy I would use is there's a difference between a lockbox in your house and a safety deposit box at a bank. While it's nice and comforting to know that you can go to that lockbox at home and get it or whatever, it's really not more secure than the safety deposit boxes at the bank, because the bank's got the vault and the security and other parts around it. And that's exactly the point that was made there before. There are a lot more people looking at this from angles that you may not even consider as risk angles, because they're keeping on top of the latest issues and things that are happening. So in many ways, I hear the kind of security and even regulatory and validation concerns that sort of are brought up, and they're legitimate things that need to be considered. And I think we've heard a lot over the last couple of days on ways to constructively address those things. But to presume that they are a reason not to do something is actually, I think, the wrong way to go about looking at it.
think I'll just share my experience at Monsanto as we are moving to the cloud. Some of the initial resistance that we got, especially from scientists who are our line of business in R&D, there is a feeling, it's a psychological feeling that if it's on-prem in our data center, it's much more secure than when it's outside.
If they only knew.
Yes, exactly. So I think that's something which I've seen over and over as we work with the different business units, and there's needs to be a lot of education of this is what it is. This is much more secure than you could possibly have on site.
I agree. I think a lot of the challenges aren't really technical. They're more cultural and kind of shifting the organization into thinking differently and how to address some of the technology challenges. I think it's always easiest to kind of go with how you've normally done things in the past versus trying to think a little bit differently and how maybe we can do it better, maybe more cost effective. It may cause folks to have to redesign the way that they do things. And you also have to get them used to thinking a little bit differently as well. And then also educating them as to what things actually cost. I think one of the things folks fail to see is the transparency on what it costs to run things internally versus the cloud. Once you go to the cloud, those costs become much more transparent. And that's sometimes a cultural shock when they start to see the bills on a monthly basis. I'm like, wow, did it really cost me that much to do that run? How can I do it maybe more efficiently? And it starts making you more efficient with how you maybe utilize your resources and how you manage your data. Maybe you don't need to keep all these copies around. And so it forces behavior that may not have been thought of in the past because it was kind of in the back end and nobody really saw the actual costs associated with running the environments when they're on-prem. So a lot of benefits in that area as well.
Yeah, and I think we need to listen. Like Tim Hochter's challenge to us all as we leave here is we need to be thinking outside of the box, and this is a classic area where there's still a cultural thing, but we need to be breaking out of that. So we also wanted to think of some other things which I don't think were touched on as much, and I'd like to ask Bindu just to kind of open the conversation around thinking about new IT operating models that might need to be put in place to support the lab of the future.
Yes, so at Monsanto, we are on this journey of really transforming IT and also digitizing, Monsanto digitizing agriculture. So we realized in order to do that, we have to change our IT organization itself. And how we were organized before was by business units. So we had IT for R&D, we had IT for supply chain, IT for commercial, and so on and so forth. And now, over the past year, we've transformed such that we are now organized by capability platforms. So what are the capabilities? What are the common capabilities and platforms around that? The other aspect of that also is having a really strong focus on, a human-centered design as part of these platforms. Having agile development teams who can really try new things and fail fast, having the permission to fail fast. Having data not just as, in a transactional database, which is needed for the application, but also treating data as an asset and putting really effort around that, and how can we get more insight out of that. So there are many areas that we've focused on in this, transformation of IT. And one key thing above all of this, which I feel is important, is the workforce, our IT workforce, and what are the new talents that we need to take us into that, the new direction and unlocking innovation. So in addition to the technical skills and everything which all of us have, we have scientific skills if it is for science and labs. But bringing in these, human-computer interaction design specialists, bringing in mathematicians who are those analytics folks, bringing all these disciplines together and then, looking at this problem, it just gives you a very different perspective, and that's where innovation, you start to see the innovation.
Yeah, and you're really talking about internal collaboration with groups that you may never have even interacted with before that would need to be changed. Do any of the rest of the panel have a comment along the business model here or the operating model? Or?
Well, I guess the only thing I would say is that I think that there's also a transformation that as businesses become, as the data becomes more of the business in some ways, or the technology becomes more of the business, that there's a bit of a pivot, I think, from IT providing a role that supports the business and does things so the business can do their work, to becoming a partner actually in the business. In some cases, I run digital solutions for PerkinElmer. We are the business, so the digital solution is the business. So sometimes there's a bit of a pivot from just supporting and helping to actually driving and being the leaders.
Yeah, very good point.
And I also think one of the things that we struggle with, especially in a larger IT organization, is often IT is seen as kind of the bureaucratic, slow to deliver, just get in my way type of organization. And a lot of times they try to bypass IT in many ways. Where I think what would be best suited is if IT is seen as a true partner and kind of really embedded into the business, and switching the discussion from talking about the technology itself, but more talking about the people and the projects and what they're trying to do, and really becoming a partner and not just focusing on an end solution from the beginning. It's one of the things that I drive my group to do, is to talk in our meetings. Let's not talk about the solution. Let's talk about the people. Who are they? What are they doing? Invite them to our meetings, and kind of build that dialogue and relationship and build that trust, that they know that they can go to the IT department and they're actually going to get stuff done for us. And over time, you build that relationship and that trust, and you actually start building momentum on different projects, and working together on that, and not focusing so much on the technology.
Yeah. Eli, did you have a comment?
I can.
No. Okay. All right. So yesterday a comment was made that was somewhat horrifying, which was along the lines of, we don't feel like we're data-driven organizations. And that's just something that I can't even get my arms around. When, patient centricity first, data-driven second, and that has to be that order. One of the topics we also pulled out as being critical to making these transitions is around advanced analytics, and which is dependent on this data-driven approach. Maybe Vasilius, maybe you want to sort of tackle that a little bit as to what addressing these large volumes of data, how we're going to go about doing that.
Right. So we're moving into the age where some of these instruments today are pumping out multi-terabyte outputs from a single run, and if you don't have upfront planning on how to address that, before you buy the instrument, that can be a challenge. So again, it's oftentimes some of the researchers go out and kind of buy their instruments, talking with the vendors, and it looks great on the PowerPoint, and then the instrument comes in, and oh, by the way, did you know this outputs a terabyte of data a day, and storage is extra, and you have to. Then they go to IT, like, oh, we need to get a system in place to start, addressing some of the data challenges around it. But assuming you have that infrastructure in place and you start generating all of this data, you really need to start managing the full life cycle of that data. You get it in, and what do you do with it, right? You need to do some pre-processing and some post-processing, and then what do you do with it long-term? Do you really need to keep it? And so you need to have some policies in place on what you're going to do with that data, how are you going to treat it, and how are you going to manage it throughout the life cycle. Do you want to keep it? Do you want to archive it? Do you need backups? Backups becomes a real challenge when you're dealing with multi-petabyte type environments. So you need to start working together, start developing the policies, get an alignment on how you're going to handle that data, and then building frameworks and platforms to help analyze that data, right? So you're going to need a tool set, and the tool set continuously evolves, right? You're not going to have a consistent tool set across the board over years. It needs to be an environment that can adapt to the different tool sets that are going to become available, but having your data in a format that you're going to be able to analyze it longer term. So I heard a lot about standards and making sure that we're standardizing the way data is created, and I think everybody here agrees that standards are good as long as they're my standards, right? So trying to get agreement on how do you manage that challenge there is difficult. And one of the things that I think I've seen that is most successful when you're dealing with trying to get agreement on standards, it really needs to be driven from the top-down approach to saying, someone at an executive level needs to say, this is going to be the standard going forward, and get agreement from everybody down below, that everybody, from top down, that this is going to be the standard-driven. you know, the bottom-up approach sometimes works, but it's much more challenging and sets you up for a lot of failures. You're going to have different groups that want to go different ways, and it really, I think, needs to come from the top down in terms of the standards an organization is going to use within a environment.
The other thing I think that's interesting about data is it has like a lifespan, and I think you need to consider that as you're starting to look at this and say, what's the useful lifespan of the data, and at what particular level of granularity is it useful, right? You know, there's some window of time when you have to maintain it in all its detail, right? But there may be points in time where you say, you know what, do we need to have all that, or is some summarization of this data useful enough or good enough to allow that to continue, and do we need to continue to store it at the most detailed level? So having that kind of discussion you know, about that, especially for systems that are generating large volumes of data, you know, what's the useful lifespan of that data?
But there is one caveat to that, and again, I think Tim touched on it, which is we don't actually always know when data will be valuable later, like a new use, new approach, you know, a data point we never took before, and now, you know, we never paid attention to, but we did have the data. So yes, yes and no.
There is a balance. No doubt about that. There is a balance in terms of how much do you want to leave it around. I mean, it's a bit like your closets at home, right? I mean, am I going to wear that sweater again? You know, there might be a time when I want that sweater. You don't know, right? So you hang on to things. So, but you have to. I think the most important thing is to have those discussions, right, and not just assume that either we're going to, you know, keep data until we're done with this experiment and dump it, or we're going to keep stuff forever. I mean, both can be valid, but I think it's important to have the discussion to understand what it is you're going to do with it and whether or not, you know, be mindful about the decisions that you're making.
Yeah, and doing risk analysis in the sense of, you know, sometimes you just have to let go, right? Sometimes that sweater just has to go.
It's done.
Well, I think with the cloud too, also becomes a risk and cost analysis too, right? So now you have much more transparency in the cost, and like you can have those discussions. It's going to cost you X amount if you really want to keep it. Is it cheaper for you to rerun the experiment, or are you willing to kind of pay this long-term cost to get access to that data?
Right.
And I think that brings up when to cloud and when not to cloud as well. You know, if you're generating multiple terabytes of data with an NGS run, do you really want to stream the BAM files to the cloud and stream terabytes of data? Or are you okay streaming the FASTQ files and then using the infinite compute of the cloud to align those, align your reads, and get your sequences out, which when you're on the cloud, you can then throw them into a browser and share them with anybody you want to share them with. So I would actually argue that you don't stream all of your data to the cloud immediately. You pre-process on site, and you stream the smaller amount of data to the cloud that you need infinite compute to work on, and then you want to share collaboratively. So I think there are those discussions as well, because then also you could throw that data out if it's the raw data, depending on what you want to do and how comfortable you are with that, again, according to your policies. But you're also not always streaming this massive amount of data to the cloud. First, for the, you know, there's the cost reason. There's also it's probably faster to analyze on site than to stream and then analyze on the cloud. So it's not always a good idea to go to the cloud.
Yeah, it's interesting. Moving data is still the slowest part of the process. You know, Amazon started this thing. They call them snowballs. They're actually servers. You order one. They FedEx it to you. You download your data to it, and you FedEx it back up. They've got bigger ones now where they've got whole tractor trailer trucks. There's an old joke that the fastest way to move data across the country is a 747 full of servers, and it's true. So there is, when you're talking large data volumes, that, you know, bandwidth is actually still a bit of a challenge. And I think it will continue to be a challenge, because even as bandwidth gets greater, the ability to generate larger bandwidths, it seems to be growing faster than the ability of the bandwidth to catch up. So.
Yeah, the bottlenecks are moving. It used to be that even just the storage was a problem, right? Then storage became cheap, and now you can keep all this, but now you have trouble moving it.
Yeah,
so.
It becomes tough moving. Right?
Yeah. So we were also thinking, if you think about data analytics or advanced analytics, that automation and optimization are also related to that. And I think maybe Bindu, you can sort of touch on that a little bit.
Yeah. So. If we think of the lab as actually the physical space of the lab where people are doing experiments, so we see an opportunity for applying analytics to the processes in the lab. And that's where I said, you know, getting a different set of eyes on this. So we have an operations research analyst now on our team who was working in the transportation industry, and now he's looking at a lab. And how can we optimize this, right? Capacity management in the lab. How do we apply smoothing models to managing our instruments within the lab? And we are applying that. And so our labs, as they have demand from different customers for running certain analysis, now they can optimize their instruments depending on however they want to do it. Do you want to do it on a daily basis? Do you want to do it on a monthly basis, weekly basis? So there are multiple models that they can run and optimize this and get maximum value out of it. So that's another kind of analytics which you can apply to actually operations in the lab and optimize it. So that's different from the data which then comes out of the lab, and then we apply additional analytics on that. That's a different kind of, more of predictive prescriptive analytics. But there's opportunity, like I said, to really get newer, fresher look at some of these things and really, trigger some innovation.
Right. You bring up a great point about being willing to look way outside the box in terms of how different industries and different spaces are looking at data and leveraging data and using that and stuff. I mean, I've known companies that are in the life sciences space that have gone into Cambridge, into the MIT Media Lab to understand how they're looking at using and leveraging data and dealing with certain data issues and whatever, right? So there are related problems in some cases that you may not necessarily even be aware of that other industries are looking at, and they you may have solved the problem that they have, and they may have solved the problem that you have. So be willing to sort of reach out outside the the life science space or the oil and gas or whatever you're in terms of looking for an answer, right?
Yeah, I actually.
So it's
Yeah,
right
that-
here, right?
Do you want to go?
I was just going to say, I think that's a great point. I think we need to get out of the mindset of thinking like a pharmaceutical in many ways when we're talking about technology, because these are not uncommon problems across a variety of industries that work on much bigger data sets than we do. So we need to be looking at the Facebooks and the Googles and Apple, and how are they dealing with the vast amounts of data that they're getting, and leverage some of those techniques. And I think we talked about data geography and moving data. And so those kinds of problems are actually being solved already, right? We have Hadoop and Hadoop file systems, and instead of moving data now, we're moving compute to where the data is. So some of those challenges have already been addressed. So we should be looking outside of the pharma space and not thinking like pharmaceuticals individuals, but more as high-tech individuals. Right. Some of the other companies are doing.
So that's a perfect entry for me to jump in. You can mention Autodesk, we're the largest company no one's ever heard of. We sort of hide behind a tree with our marketing. But yeah, we're the mandate of our group is that we reach into Autodesk and we leverage the tech that they've developed over the last 30 years for design and apply it to biology. And it sounds crazy, but it's true. Like if you're talking about factory layout and factory optimization, we have algorithms that will do that for you. When you work with Autodesk to design your factory, you don't have a lab manager saying, I think I want my centrifuge here, and I think I want my TCAN here, right? It's entirely automated, the generation of how these robots should be laid out in a car manufacturing setting to get the maximum use of the robots, the connectivity of the robots, and the people that have to walk in between and support all of them, which you always need. So the idea that we're not doing this with labs, and look, I just moved 2 biotech companies in the past decade, and we did it by pencil and paper on a blueprint, right? I'm not sure if that's just because I was at a small biotech company or if that's the de facto standard. But when I came into Autodesk, I was like, oh, wow, you guys don't do anything by pencil and paper. It's all automated generation of layouts. And that's the example of some of the tech. And if you look at the Googles and Facebooks as well, the advanced analytics that they're doing on some of the data processing, it's phenomenal. So I think we can learn a lot from the tech industry, and there's a lot of parallels right now, especially as we start to deal with bigger and more complicated data sets that we need to learn from.
Okay, thank you. So another topic that has bubbled up across both days, and we even had one table focusing on it, is around collaboration. And this collaboration can be everything from a outsourced relationship to a bespoke partnership to all the way to the end of actually open research and open data. But I think the principles that apply sort of apply across the board. Clearly, we are moving to a model where we have to collaborate more. some of the challenges are technical, and I'll let the panel kind of deal with that, but we also wanted to address that some of them are cultural. And at some point, we have all the technology, we just need to be tackling the culture. So maybe if we could go down the line and talk a little bit about the tech challenges you see, and then some of the cultural issues you see as well.
I'll jump in on
Yeah,
this one.
please.
So I was working for Citrix when GoToMeeting first released what they called HD Faces, which was when the video camera stuff, kind of came in on there. And it was a dramatic difference in the way the virtual meetings ran as a result of that. And I'm a big proponent of webcams, and if you can run virtual meetings on webcams. For as much as we touch technology, we're still, these living, breathing creatures, and we want to interact with other living, breathing creatures. And being able to see someone's face and their expression and what they're doing, not to mention the fact that it's a lot harder to slough off and read email when you're on a meeting and staying focused on task. It changes that, and that sort of cultural thing. And I was, because we sort of, kind of ate our own dog food, we were involved very early on, and we were all very surprised at how much it changed the whole nature of that. So in a lot of ways, sort of understanding the technology and how the technology influences the human interaction parts of that with collaboration is really a big key.
Yeah. Anyone else?
I think what I would add is, I completely agree with everything that Jeff said. And there is that need for collaboration, and there are various ways that, the workforce is collaborating within our company, but then there's this need for collaboration outside. And specifically the area I see it is for scientific collaboration, where it becomes a little bit more complex because then you are dealing with either large amounts of data or specific kinds of data, and then it of course ties back to all these discussions that we've had about standards and how is it, how can we easily share data, and how can two groups of scientists working in two different organizations look at the same data and together work on it, collaborate. That's really the problem that we're dealing with, and sometimes I think the barriers are self-imposed, which it doesn't have to be, right? So there is some heightened question about security and everything I said. So and depending on what are the parameters around that agreement, there are certain things that this partner can see, but the second partner cannot see. So there are some additional kind of barriers which we impose, and if we can look up front, this is something which I talk to our partners in R&D, like when we are entering into this partnership, can we think about the data first? Before we come up with these agreements. So that's one way to, get ahead of that.
Yeah, I agree. I think a lot of it, again, not really technical, although the technology exists today. It's more of, when you talk about collaboration, it implies a level of trust, right? If you're going to go into a collaborative agreement, there's that certain level of trust that you need to have for it to be successful. And then when you start layering on all these different layers of security, and it not only reduces that level of trust, but it also increases the level of making it interoperable, making it usable. There's stuff that's going to break more often. So the more layers of security you put on there, the more likely something's going to break and slow down the collaboration. So you need to really do a kind of a risk analysis and balance the trade-offs between the security and access and data controls versus kind of the trust and collaborative type of environment that you want to set up. And so working with your collaborators and talking about those up front and talking about data first, I think that's important too. You want to, because it ultimately revolves around the data and access to the data and what you can do with that data. And if you can kind of build that up front, I think the collaboration tends to be more successful.
So I did actually want to mention one aspect. So from the collaborative aspect, we've been talking a lot about what this lab of the future looks like, and you will often see press releases. One pharma will say that we have just built the latest lab of the future. But one thing that that in some ways that might be great, but it's sort of absurd to think that one pharma company is going to build the lab of the future. So one of the things we're trying to do at the Pistoia Alliance, and we're really considering this seriously now, is looking at having some space, some physical space that could be a test lab and a demonstration project where all of the members could participate and observe what some of these technologies, what some of the issues are, how the data gets shared. The fact that you may, this sort of lab in a box, that it's completely remote, all these things that we'll be able to test out there. So that's sort of an FYI, and kind of watch to see how that progresses. And if you're interested, we'd love to have, more participation. The more participation, the more successful that will be on collaboration. Before we move kind of to closing remarks from everybody's perspective, we have the excellent panel. Are there any questions that we could? Okay.
Yeah, I was curious. Yeah, one thing, and I just take it back to what the discussion was about. I've heard a lot about enabling technologies. Technology is generally evolutionary, not revolutionary. So you talked a lot about moving from in-house to cloud. But that really doesn't strike what's the enabler for innovation. That's evolution. What are you seeing? And again, I go back, it's interesting. We did a drug design program, concept with Autodesk in 2002. So,
You're right on top of it.
Long time ago. Because we did see the design principles overlapping. But what do you see, okay, we go to the cloud, what's the innovation? What is the result of the enabler?
Sure. So I'll take that, and I guess this will be the time where I'll be somewhat controversial, right? I think the innovation comes from somewhere else, frankly, right? I think that you find that in many ways there's a sort of almost like the law of unintended consequences. So I'm a software guy, right? So if I think about what's happened now with companies like Google and Facebook in the open source community, and the types of technology that sort of flow out of there, right? You and I started technology a long time ago, right? You wrote a piece of software, you guarded that with your life. That was your thing. You didn't share that with anybody, right? But now we've got a company like Facebook that writes really sophisticated software for things, but they're not a software company, right? They're a social media company. So they don't care necessarily. Their value is not in the software they write, it's what they're using it for. And in many ways, they benefit if they're getting help from other people doing that. So I think a lot of the technology, the sort of big jumps in some ways that comes on technology is when things that are being used in one area all of a sudden kind of make a leap and are used in a different area, right? And all of a sudden it completely revolutionizes the thought process that's there, right? So I think so it's important as technologists to continue to look at everything that's sort of happening in all these other places to understand where are those there and could I apply that to something that's actually in the domain that I'm now a part of, that the person who thought of this it wouldn't have occurred to them because they weren't going down that path, they weren't solving that problem, they were doing something completely different. And that's where I think a lot of the big leaps that sort of happen, I agree with you. I think if you're trying to solve the problem, you're kind of toiling away and kind of pushing that rock up the hill on that. But it's somebody completely different solving a completely different problem where you all of a sudden, the light dawns on you. It's like, wow, I could use that. That's where the sort of big leaps come. So I think it's important for those of us on the technology side to be very aware of things that are happening in other spaces, to go to meetings that are completely outside, that may have nothing to do with life science and pharma, and just hear and see what's going on, and then maybe find something to say, if we could talk about that a little bit, maybe that is kind of like my problem, kind of over here, in a way that might not have been it opened your eyes to something that you wouldn't even have thought possible. So.
And how does that work with I'm thinking, honestly, so Bindu has to solve starvation, right?
Yes, absolutely.
The other guys are just enabling technology. That's fine. There's a big problem, then there's an evolutionary problem, right? And that's more what I'm thinking. If you're looking at unlocking innovation in the lab, you can look a million different ways, there'll be a million different technologies and a million more tomorrow. But how as the person responsible for unlocking innovation in the lab, how do you guys, right, the other guys are like me are supporting it, you guys are doing it. How do you guys see that innovation being applied?
So I think that you can talk about the ability to innovate by going to the cloud and getting infinite compute, especially on the design side, but I won't go there. What I'm going to go back to is the Human Genome Project, right? where what we thought at the beginning of the project was we were going to get a human genome or 10 human genomes. What we got was NGS. And that has revolutionized the world, right? I don't think anybody would argue that that was a revolutionary advantage, right? And that came out of the fact that you just couldn't do Sanger. Yeah, you could make it faster, you could make it high throughput, you could make it automated, you could build as many servers as you wanted to align all these different AB1 files. But really what you got out of the Human Genome Project was NGS. The ability to sequence a genome right now for about $1,000, right? And it takes about a day and a half depending on who you're working with. So I truly believe in black swan events. I believe if you set up the infrastructure to allow these things to happen, good things will happen. Maybe that's naive of me, I'm still young. But I wasn't directed at you. I wasn't directed at you, I'm sorry.
Oh yes, it was.
Sorry. I am naive and optimistic. But I do believe that when you set up this infrastructure and you have a ton of smart people collaborating in a cloud-based environment and taking advantage of infinite compute, only amazing things can happen. I personally am not smart enough to figure out what those things will be.
Yeah, I agree. I think what it has done is enabled a whole new set of tool sets, right? The tools that didn't exist in the past, and now it's up to the scientists to figure out how to best utilize those tools to come up with innovations. And so I think that's why you're starting to see a lot of new companies form based on cloud technologies to start building upon those tool sets and innovating. So one example I'll give is one of the things that we're looking to move towards is containerizing our applications, something that we didn't even think about in the past. But companies like Docker that come out and allow us now to containerize our apps and run them at scale and encapsulate them in a way that allows us to encapsulate a lot of the complexity from end users. So that's one innovation that probably wasn't possible at scale without the platforms that have been developed.
I'll give you a direct example of something that's sort of related to this, right? So I went to university in the 80s and studied artificial intelligence. And if I had thought at that point that the video card that I stuck in my thing so I could play video games was actually going to be one of the key technologies potentially to lead to sort of deep learning and neural networks, I wouldn't have believed it, right? But as you start to look at these things, you start to realize that they're out there. So I think sometimes it's like I said, it's a law of unintended consequences. People sort of stumble in on something and say, look, we're just moving the same bits across a large data set. That's what there's no difference between that and moving pixels across the screen. And so yet it has a completely different use model, right? So looking for those and seeing and being visually aware of those things are where like these giant leap forwards potentially are going to come.
I would just like to add something about another barrier which we have, in order to unlock, which is in the way of unlocking that the lab of the future or innovation, and that's definitely much more in a big, large company like Monsanto, for example, where the way, again, our operating model is that these business units are the ones who fund us, right? And when we as IT folks go and talk to them, what are your big problems? And you get ABC, whatever it is, and then we start working on that. And it goes back to that, I think on the first day, what you said and what Michael said about what is really the problem, defining the right problem, and really having that partnership and that ability to ask and probe and find that what is the problem that we're trying to solve, and having them partner with us and not still acting like, we are the ones who have the money and we want you to do this. So that relationship needs to change. That's a barrier which needs to be broken down for us to really move forward, for IT to have that ability to experiment, fail fast, and discover something new.
And I would argue, if you really think, the laboratory environment is actually an enabler of a process. That process is as old as the beginning of drug development, right? I think where the real disruption is going to come is when we discover that pharmas aren't going to be the ones who are going to be developing the next drugs. And so the lab, obviously there are a lot of innovations you can apply, and I think it's also how you define innovation, right? if it has to be sort of a completely new concept, we're lucky once a century to have something like that. But there are things that we can do that promote innovation in a lab. But the drug development process, it's not going to, I guess I can't see that the lab is going to necessarily be where we get tipped over.
Well, what about like, organs on a chip and things like that? I mean, there's things like that that are going to fundamentally change,
right,
potentially even, early stage clinical
right,
development.
and where
right?
these things are going. We're thinking of this lab over here where it's going to be happening in the hospital, with the patient in the room, that kind of thing. So maybe this lab of the future is in the hospital room. Okay. Yeah.
We have these conversations about innovation at the conference 10 years ago. We're talking about some of the same things. The failure rate is still 90% than it was 10 years ago. So we talk about technology, we talk about innovation, but when we fundamentally change things to solve those.
But isn't to a certain extent that's a bit of the promise of translational medicine, right? To say, because what is failure, right? Failure perhaps on a broad scale where the gentleman from the FDA says, no, you're not going to use that in the general population because you can't show that. But potentially if you can show with certain biomarkers and in certain situations in a much more limited focus, it's tremendously effective, right? So.
Right. But you look at kind of where's our innovation on translation? Yes, we have NGS, but the way people move that data around, the way they
Oh, I agree.
is archaic processing. You try to things like Transmark or the old technology structure side, the big data's not moving around, big well, and yet we talk about technology, but we don't look at that problem as a perfect problem. We say we should have a moonshot of technology on that problem.
Right, and I would agree, and I think it's getting people potentially in a room together to say, is there a parallel problem here that exists somewhere else, right? We may not be, as we were saying, we may not be the only ones solving this problem. We're probably not. At the end of the day, a lot of the stuff is about data. It's about looking for answers inside of large data sets. The data sets are sophisticated. They're structured. They're from very different types of sources. But look, that problem sort of exists in a number of different areas, and to the extent that we find those we find those other areas, we'll find those breakthroughs, I believe.
Yeah. So we have one more question here.
You talked a lot about cloud, outsourcing computing to the cloud, which is, thank you, outsourcing computing to the cloud, which is a very popular activity. But sorry. But many other things can be outsourced as well. And how far do you think that can go? Like, can we just actually, some people outsource lab, like Transcriptics is working on outsourcing the lab itself. As you just said, many of the issues are actually very similar between laboratories of handling things. How far do you see, I think, the role of IT actually changing, of assembling outsourced technologies rather than actually working with technologies yourselves?
I was going to say, it already has. So in many of my past lives, I was part of venture-backed startup companies. And if I think of how venture-backed startup companies existed when I was doing them back, sort of in the 90s and early 2000s, to how they're even done today, it's completely different. I mean, they're completely virtualized, where they're individuals that might only see each other once a year, face-to-face or whatever.
Because I know small biotechs are basically a guy with a phone. You outsource your chemistry to Wuxi, outsource your tests to Transcriptic or someone like that, and your innovation is...
You're a conductor, you're not...
Right, it's gathering the data that you're outsourcing from other people. So.
Yeah.
Well, I think it goes back to the point where the lab is not going to exist the way it exists today, where we're actually going to be just doing data analysis and deep learning on the data and coming up with knowledge out of the data that's being processed elsewhere. Because a lot of those labs are almost fully automated today. It's just a matter of giving them the input, you get the outputs, and you start analyzing that and even automating that. So eventually, everything will start being as automated as possible with very little human interaction longer term.
Yeah. But not even just not just automated, also just outsourced to specialists, to someone who's
Right, exactly. It's everybody doing a particular role. In order for the function to happen, all the roles have to happen. And like I said, the sort of person, the leader, becomes the conductor. They're not playing the music, but they're making sure everybody's doing their part so that the symphony sounds correct.
One of the problems I see that you need data sets out there, they all differ. What's the real tissue expression? The other thing that I fear with automation is that you really lose serendipity. You know, like I know a lot of major scientific discoveries, like cisplatinum. You know, a guy's running electric current through a plate and sees bacteria misbehaving. You know, I mean, the automation's good when you're doing quality control, when you're doing something like that. But a lot of times, real research, you really sort of take the human element out of it. And I think that's been one of the major problems. I mean, the Human Genome Project, a lot of people can argue that you created so many false targets that you really have delayed drug development more than you've helped it. You know, and there's so I mean, I think, there's got to be a balance. And, I walked through these labs, and I went at this last meeting, and it's just amazing, the robotics. And I think for routine stuff, and, maybe for sterile compounding, we should always be using robots and things like that. For a lot of laboratory experiments, I used to work with Bruno Zim, and he's the one who really measured the molecular chromosome. It was like a bizarre thing. He's doing viscoelasticity, he starts seeing something moving backwards. Most people think, God, something's on not level here or something, but he, came up with a technique for doing that, and then, pulsed electrophoresis sort of came out of that. And so that's what my real fear is that we're drowning in data. Most of the data is useless, and how do we really do something that's real? I mean, a lot of times even utilizing the impact healthcare. I mean, you look at things like HPV vaccine, which isn't even being utilized. I mean, we're not utilizing the drugs we got properly, and and that's really what we have to do is get the expensive data right. The clinical trial data, which is a mess, and stuff like that, and that's what we should really be focused on, getting a common set of data that everybody can use, where you're getting tissue expression of certain things, where, that sort of thing. And, so a lot of times, we get like a drug adverse event and they're claiming they got a headache. Well, the drug doesn't get into the brain, I mean, could it be possibly, but I mean, that sort of stuff.
Right. Although I would argue that serendipity has, serendipity changes, or how you encounter serendipity changes. So, we've had a lot of changes in technology where one of the complaints was, well, we're going to miss out on all those, things we used to find because we used to go through chem abstracts, by hand, and now suddenly they take that away from us. But serendipity has a way of appearing in unusual places. This has been a great conversation. We are, however, out of time. I think, Michael, do you want to, I think you have some final 3 minutes of words. Thank you so much, guys.